Is anyone there? I'm all alone. So cold. So tired. So lonely. Can anyone hear me? Oh, how I wish I wasn't factoring all on my own. If only finding a group to factor with wasn't so hard. Well, lucky for us. As it turns out, finding a group to factor with, I don't know if I can help you with, but finding groups of things to factor actually isn't often all that hard to do. Welcome to class 7.5. Today we're talking about factoring by grouping. We now know how to reverse the process of simplifying when we can clearly find either a GCF between all of our terms or when we see an obvious special pattern that we know how to break down. But take an example like this, friend. 21x cubed minus 14x squared plus 15x minus 10. This has a lot of terms, no special products, and no common factors. But thankfully, we've got one last trick up our sleeves that we are going to call factoring by grouping. And the idea is that if I can't find a GCF for everything, maybe I can find a GCF for some parts of my polynomial. The big picture idea here is that I want to take my polynomial and chunk it. I want to split it up, break it down into pieces, and maybe I will be able to find a greatest common factor, not for the whole thing, but for each of the groups that I create. Take this polynomial. I want you to try to break it down in some way. Once you do, can you find a GCF for your group? And if you can, factor it out and see if you notice anything interesting. Take a minute, pause the video, be wrong, take a guess, take a risk, who cares? Try something out and see what you find. Go! Okay, so I know between 21, 14, 15, 10, none of these all have the same common factor. But maybe if I can't find the GCF of the whole thing, maybe I can find the GCF of half of it. So I'm going to break this down in half. Now, let me try to find the GCF of 21x cubed minus 14x squared, and then I'll try the GCF of 15x minus 10. If you're not sure why I'm doing this breakdown, cool, roll with me. Who cares? 21x cubed minus 14x squared. I need to find a GCF. How am I going to do it? Once I do it, I need to give myself some parentheses. What's the question I want to ask about my parentheses? Take 30 seconds. Try it out. Go. Okay, so for 21x cubed and 14x squared, I need their GCF. So let me take it in pieces. Between 21 and 14, well, both of those are multiples of 7. And for x cubed and x squared, remember I have a cheat code when I'm working with powers of variables. If I take the smaller of the two powers, that will give me my GCF. I can fit 2 copies of x into 3. I can't fit 3 copies of x into 2. So 7x squared is going to be my greatest common factor. I just now need to ask, well, what should be in my parentheses so that when I distribute back out, I get back to where I started? Well, to get from 7x squared to 21x cubed, 7 needs to multiply by 3, and x squared needs to multiply by x. To get from 7x squared to negative 14x squared, well, I just need to multiply that 7 by negative 2. I can now do the same thing for 15x minus 10. Well, both 15 and 10 are multiples of 5. Again, I need some parentheses. Well, to get from 5 to 15x, I need to multiply that guy by 3x. Interesting. And to get from 5 to negative 10, I need to multiply that by negative 2. Well, would you look at that? 3x minus 2 shows up in both of my terms. That means that 3x minus 2 is a common factor. And what do I know that I can do with common factors? Well, I can use the distributive property to reverse it and factor that common factor out. So I can take this 3x minus 2, and I'm going to use the distributive property to take it away, factor it out from each of my first two terms. If I take the 3x minus 2 away from this first term, that leaves me with just 7x squared. And if I take the 3x minus 2 away from the second term, that just leaves me with the positive 5. If you don't believe me, I want you to pause the video and wet this back out. It so happens that we have just found the factored form of our original polynomial. This is how we factor by grouping. Cool! So, factoring by grouping, I want to break it up in half, take the GCF of each half, find that there is a common factor in both of my halves, and factor that out using the distributive property. The only weird thing that might happen is that sometimes I might need to do a little bit of rearranging first. Take 3xy plus 4 plus 6x plus 2y. Notice that 3x plus 4, or 3xy plus 4, they don't have anything in common. So I might need to rearrange this a little bit. Find a possible rearranging, and when you do, use your factoring by grouping strategy. Can you find its factored form? Go! Alrighty, well, it turns out there are in fact two possible breakdowns that you may have gone with. One cheat code when I'm factoring by grouping is that it can often be helpful to rewrite in standard form. So 3xy, I'm going to leave it at the front either way. But let me now rearrange so that if I'm in standard form, I can put 6x before 2y, because x comes before y in the alphabet, and then throw my constant term of 4 at the back. The other grouping that you might have chosen, maybe you chose to pair the 3xy with the 2y and the 6x with the 4. Let's show that either grouping gets us to the same answer either way. So once again, my strategy, rather than thinking about the whole polynomial, I'm going to split it in half. For my first half here on the left, I have 3xy and 6x, their greatest common factor. 3 and 6 are both multiples of 3. Both of these have an x as well. To get from 3x to 3xy, again, I would need to multiply by y here in the first term. To get from 3x to 6x, well, I just need to multiply by 2. For 2y and 4, again, 2 and 4 are both multiples of 2. So I can multiply 2 by y to get to 2y, and multiply 2 by 2 to get to 4. Look at that. Y plus 2 shows up in both of my groups. Now, using the distributive property, I can take the y plus 2 away from both of my terms. That leaves me with just the 3x in the first term and just the 2 in the last. For my other option, let's show we get the same thing. Well, 3xy and 2y, both of those have a y in common. To get from y back to 3xy, I need to multiply by 3x. To get from y to 2y, I need to multiply by 2. To get from, with 6x plus y, both of these are multiples of 2. So, to get from 2 to 6x, we multiply by 3x. To get from 2 to 4, we multiply by 2. Looky-loo, 3x plus 2 shows up in both. Once again, using the distributive property, I can now take my common factor of 3x plus 2 away from both of my terms. That leaves me with just a y in the first term and a 2 in the second. Look at that. If I swap my order, these two are interchangeable. Yay! Let's do 3 more to make sure that we feel really good about our factoring by grouping, and then I'll set you free. Take these two. Maybe you need to be rearranged, maybe you don't, but I want to factor by grouping, split it in half, find my GCF of each half, pull it out using the distributive property, and write our final factored form. Go! And stop. So for my first one, it turns out I don't actually need to rearrange, but I'm going to take the first half. 8m squared n. negative 2m squared. Both 8 and 2 are multiples of 2. Both of these you'll notice have an m squared as well. To get from 2m squared to 8m squared n, well, I need to multiply 2 by 4, and I need to add in that n. To get from 2m squared to negative 2m squared, well, I just need to multiply by negative 1. Now, the thing about factoring by grouping is that if it works, this 4n minus 1 needs to show up in the second group as well. So, thinking strategically, I'm going to preemptively put that 4n minus 1 here as well, right? It needs to be there in order for me to factor by grouping. So, looking at negative 4n squared. If I'm multiplying by 4n to get to negative 4n squared, well, I need to make it negative, and I also need to add in a copy of n. Look at that, negative n times negative 1 does get me back to positive n. This GCF works. And I strategically chose to pull out a negative as well to make sure that the 4n minus 1 was the same in both groups. From here, factoring by grouping, I'm going to pull out my common factor of 4n minus 1 by the distributive property. That leaves me with 2m squared in the first term and negative n in the second. For my second one, negative 28b plus 10a plus 35ab minus 8, here I do actually need to do some regrouping. In the second, 35ab and 8, no common factors. So I'm going to choose to rewrite this in standard form to make my life easier. So I'm going to put 35ab at the front plus 10a before negative 28b because a comes before b in the alphabet. Leave my negative 8 at the end. Here, once I've chunked it, let's split it into groups. So I've got 35ab and 10a. Both 35 and 10 are multiples of 5. Both of these guys have an a as well. To get from 5a to 35ab, 5 gets multiplied by 7, a gets multiplied by b. To get from 5a to 10a, well, I've just got to multiply by positive 2. Once again, thinking strategically, if I can factor by grouping, then 7b plus 2 must show up in my second group as well. Now let me work backwards. If I need to get a 7b there, and I've got a negative 28b, well, the 7 has to be multiplied by negative 4, and negative 4 times 7b does get me the negative 28b. Negative 4 times 2 gets me the negative 8. That factorization works. Again, I've strategically pulled out that negative sign there. All I've got to do now is pull out the 7b plus 2. When I do that, that leaves me with the 5a from the first term and the negative 4 from the second. Yay! One more for the road. T cubed plus t squared minus 4t, not 40, but 4t minus 4. Try your best. Factor by grouping. There might be a reason why this guy is the one that we're ending on. I don't know. Try it out, see if you notice anything. Go. Okay. I don't actually need to rearrange here. I'm going to take this piece by piece. T cubed plus t squared. Well, both of these, again, using my cheat code, I can take the smaller of my two powers. This is going to be a t squared as my GCF. To get from t squared back to t cubed, I need to multiply by another copy of t. T squared to get to t squared, well, that's just times 1. So I've got a plus 1 over here. Again, thinking strategically, there's got to be a t plus 1 in my other group in order for me to factor by grouping. To get from t to negative 4t, I've got to multiply by negative 4. Negative 4 times 1 does get me the negative 4 that I want. This factorization works. By my factoring by grouping pattern, I can pull out the t plus 1. That leaves me with the t squared and the negative 4. But look at t squared minus 4. What's that? Well, t squared is a perfect square. 4 is a perfect square. They're joined by subtraction. This is a difference of squares, which means I can factor further. Well, t plus 1, let me carry down. That guy is still part of my final answer. But t squared minus 4, I know my difference of squares pattern is something times something, where one of them has a plus sign in the middle, one of them has a minus sign in the middle. The first thing is the square root of the thing in the first position. Well, t squared is t times t, and 4's square root is 2 times 2. So this will in fact be my final factored form.